Hi, we are going to see about maximal frequent item set and closed frequent item set in this video. I will explain you with an example. So as we see in the previous videos about a priori algorithm, we know about what is frequent item set. To brush up, a frequent item set is an item set whose support is greater than or equal to a minimum support threshold which we have. Okay, so when we come to the maximal frequent item set definition, it goes like this. Maximal frequent item set is a frequent item set for which none of its immediate supersets are frequent. When we call a particular set as frequent, when it satisfies the minimum support threshold which it is given to you. Okay, then only we will call a particular set as frequent set. Okay, so when we go to the closed frequent item set, the closed frequent item set is a frequent item set for which none of its immediate supersets have the same support count as itself. So what this one says, so when we take these supersets and see, it won't have the same support count as itself. Okay, so let me explain you with an example. So see this transactional database which we have. In this we have 4 transactions and the list of items associated with each and every transactions. So first what I'm going to do is I'm just going to take all the elements in the transactional table and all the combinations of these elements, and I'm checking out in how many transaction all these combination occurs, and I'm taking the count of each and every combination. Okay, once it is done, for this example I am having my minimum support given as 2. Okay, now I am coming to this definition. First definition is closed frequent item set. So what it says, closed frequent item set is a frequent item set for which none of its immediate supersets have the same support count as itself. Okay, for example, I am taking A. A is having a support count of 3. And which are all the immediate supersets of A? It will be AB, AC, AD, AE. And I'm seeing how many count each and every thing has. So here if you see, AB has 1, AC has 1, AD has 2, AE has 1. Okay, when we see any of this matches this one, this count, no, none of the immediate supersets have the same support count as A, right? A is having the count of 3, but none of its immediate supersets has the count of 3. Okay, so I call my A is closed frequent item set. Same way when I come for B, B is equal to 1. Which are the immediate supersets of B? It can be BC, BD, BE, etc. Okay, when I see BC is having the same support count as B, and BE and BD are not having, but BC is having the same support count of B. So I can't say my B is closed frequent item set. Okay, and I'm moving on with C. C is having the support count of 2, and the immediate superset of C you have to see. When you see that none of its immediate superset has the same support count as C. So I can take my C as closed frequent item set. Same way go for D. D, if you see its immediate superset is having the same count as itself. So I can't take D as my closed frequent item set. We can move on with E, and we can move on with all the other sets, and we can see A, C, E and AD are closed frequent item sets. Okay, so these are the closed frequent item sets. So we move on with the maximal frequent item set. So maximal frequent item set is a frequent item set for which none of its immediate supersets are frequent. Okay, for example, I'm going to A. Okay, A is equal to 3, and I'm taking my immediate supersets of A comma B, A comma C, A comma D and A comma E, and I'm seeing the counts of that. So if I see this AD is having the AD is frequent. Why AD is frequent? Because it is satisfying this minimum support. If particular set satisfies the minimum support, then I call that set as the frequent set. Okay, so I can't call my A as maximal frequent item set. Okay, same way I move on with B, and then I move on with C. When I come to C, I am checking with my the immediate supersets of C. Okay, if I see the immediate superset of C, none of the immediate superset of C are frequent. Okay, so I can take my C as maximal frequent item set. Same way, D, if you see in D, when we see the immediate supersets, in immediate superset, one of its immediate superset is frequent. Okay, when one of its immediate superset is frequent, then I can't say my D is a maximal frequent item set. So I can't include my D. Okay, and I'm moving on with my E. So here if I see none of its immediate superset is frequent, so I can take my E as maximal frequent item set. Okay, same way I'm doing for all the other sets, and I'm finding it out. My C, E and AD are maximal frequent item set. Okay, so I guess you have understand what I have told you. So here if you see, all maximal frequent item sets are closed frequent item set, but all closed frequent item set are not maximal frequent item sets. Okay, so if you like this video, just share it with your friends, and if you have doubts you can comment on this video and I will clarify your doubts. Thank you.